proving identities. So what's the aim when we are trying to prove identities? Well, our aim is to start with the left-hand side and get to the right-hand side, put simply. It can be done from right-hand side to left-hand side the other way, but usually it's more difficult to do this. I say usually. 99% of the time it will be left-hand side to right-hand side. So how do we achieve this? How to achieve this above aim of proving identities? This we do by, first of all, comparing the left-hand side and right-hand side angle. If these angles are different, then it's likely that double angle identities would have to be used. Now notice this starting, the first thing that we consider is very similar to the how-to of solving trig. We need to ensure that the angles are the same. If they're not, we need to use likelihood double angle identities to get them to be the same. So let's take a look at one proof without going into detail. I've got here, first thing I'm going to be looking at is, do I have the same angle on both sides? I've got single theta, I've got double theta. I don't. So straight away, I know that at some point I'm going to have to use a double angle. Here's another proof question. I can see here there's a double angle here, there's a single angle here, there's a single angle here. So chances are I'm going to have to change this function to a single angle using my double angle identities. So that's our way in. That's the first thing that we need to consider. So after you've considered that first thing, what is it that we then need to do? Well, we need to then, with these proof questions, compare the structure of the left-hand side to the right-hand side. Okay, compare the structure. And if right-hand side has one term and left-hand side has two, then combine left-hand side terms by adding fractions to make one term. So what do we mean by that? Well, let's take a look at this. Suppose we've got something like this here. It's a proof question, but look at my left-hand side. I've got one term, two term. Look at my right-hand side. I've got a single term over a fraction. So chances are I'm going to have to combine these two. And the only way I can do that, I'm thinking here is, okay, I might write down sec as 1 over cos. I might write down tan as sine over cos, and then I'll have fractions there. So 1 over cos 2a plus sine 2a over cos 2a. Straight away I've got fractions, but I know how to combine a fraction by making the same denominator, and then I've got it combined. So that might be my starting point. Combining it to one fraction, because on my right hand side I've got a single fraction, whereas on the left hand side I've got two. So this is kind of referring to the point which I've just made about comparing the structure of the left hand side to the right hand side. Just before I continue, I just want to check someone's not muted. I'm going to mute whoever's not muted. Can you check your microphones are muted, because I don't want any background noise, please. Okay. So comparing the structure we talked about. Then check left-hand side terms. Right-hand side, if the right-hand side has a fraction and the left-hand side doesn't, then introduce a fraction to left-hand side by using identity or writing over 1, because we can write any terms as over 1. And we've actually done that in this particular example. We've seen that the right-hand side has fraction, left-hand side didn't have a fraction, but I used an identity that introduced a fraction, which I then combined into a single fraction. So then my structure is looking the same. The left-hand side is looking similar to the right-hand side. And that then I'm going to work with the algebra and the tidying up and manipulating to try and get it to the same as the right-hand side. So that's what we mean by, if there is a fraction on the right-hand side, start by looking to introduce a fraction on the left-hand side. Let's go and take a look at my other points that we made here. So we addressed the fraction, and last point that I made is always compare left-hand side to right-hand side at each step to see what identity relates the left-hand side function to the right-hand side function. So we need to be always looking at every single step, and that will give us an idea as to what the next step is likely to be. So the difficulty of the trig equations is that every question is very different, and you won't see the clear end sight straight away when you begin the question. Okay, you have to get on this journey and you have to apply these strategies that we've outlined here to tackle these questions, and that should take you to the end goal, what we're trying to get to. So let's go and take a look at the application of these. With my right hand side, I think that will help, because I've got on the left hand side I've got a simpler function, on the right hand side I've got more going on, and it's easier to go from more to less. So I'm going to start off with the right hand side on this occasion, and I'm going to write down my right hand side, tan theta sine 2 theta. Firstly, comparing the angle on the left hand side, we've only got 2 thetas, so somehow we have to get this tan theta to become something with just involving 2 thetas. So first thing which I'll write down is I'll probably rewrite this tan theta as sine theta over cos theta. I'm trying to bring it down to sines and coses, because on the left hand side I've only got cos, and I mentioned one of our strategy is to try and get it to sines and coses if we can, because from there we can go to any identities, because sine and cos are our base trig functions. Keep that the same, the sine 2 theta. So we've got it there. Then let's take a look at something here. This sine 2 sine theta, obviously the left hand side's got double angle. We need to get to double angle, but it's only got cos 2 theta on it. So I'm going to, in order to get it to a double angle involving just cos 2 theta, I'm somehow going to have to combine these first. So what I'm going to do at this stage is I'm going to write everything in terms of single angles, the same angle, single, and once I simplify and tidy things up, then I'll try and introduce the double angle again. Because otherwise it's hard for me to go any further here, because I've got single angles, sine theta over cos theta, and this sine 2 theta on its own, and it's hard to tidy this up or combine them. So get them all to the same angle. It enables us to use identities to change it about, to manipulate this trig identity a lot more. So sine 2 theta can be written as 2 sine theta cos theta. I'll write my sine theta over cos theta here. Now straight away you can see here that since I've made this double angle into a single angle, they're all singles now, I can actually tidy things up a lot more. I've got a cos theta there and a cos theta here, so I can simplify it a bit further. So I'll write this out. It becomes sine theta. In fact, it actually becomes 2 sine squared theta. Okay, I've got 2 sine squared theta. So then at this stage here, I'm thinking, okay, I've got 2 sine squared theta here, my right hand side, but my left hand side has just 1 minus cos 2 theta. So at this stage I'm thinking, okay, do I know any identities that relate sine squared theta to cos 2 theta, which is the double angle I'm trying to get to? And I can straight away think of a double identity that we should know. Cos 2 theta is identical to 1 minus 2 sine squared theta. So at this stage here, I've got that. So I'm going to go and rearrange to this identity such that I get 2 sine squared theta. And I can see there's a 2 sine squared theta. So I'm just going to rearrange that because that's a negative 2 sine squared theta. So I need to just make that positive. So then I can write that out, just manipulating that by adding 2 sine squared theta to both sides and minusing cos 2 theta. I end up with 1 minus cos 2 theta is identical to 2 sine squared theta. So all I've done is I've manipulated my identity there. And here at this stage, I'm going to go and substitute instead of this 2 sine squared theta with my identity 1 minus cos 2 theta. 1 minus cos 2 theta. I compare this to my left hand side, which I'm trying to get to, and I can see that this is the left hand side as required. Okay. And so I've proven that identity. This was an example where we started off with the right hand side to go to the left hand side instead. Why we chose that was because there was more things happening on the right hand side. It was easier to manipulate more identities into the left hand side than going from left hand side to right hand side. So let's go and see how we might use the result from part A to do part B. So I don't need my part A working out whatsoever, because part A was a prove that question. Okay, so the similarities between the part A and part B, tan theta sine 2 theta, here it is. It's appearing here in a slightly different form. It's got square on it. So what could I do potentially to get that part A to look like the same thing? So I'm going to start off with part A, and I'm going to try and manipulate that to make it look like the same thing. So how could I get that right-hand side, which is tan theta sine 2 theta, how could I make this the same as that? Well, that's got a square on the tan squared on it. The sine 2x remain as it is. Hold on a second, let me just check this. So I've got the right thing. Yeah, that's fine. So what we could do here is, let's see. Yeah, so we can manipulate this a bit here. This here, I can actually rewrite as 3 tan x sine 2x. Now, all I've done is I've split up the tan squared into tan x. Why did I do that? Because my original part A had only tan x sine 2x. So I've got tan x here, sine 2x. So now I've got it looking like exactly what was on part A. Okay, so I've manipulated that. So I didn't need to really focus on that bit there. Rewritten that as that. So going from here, what can I say? Well, I know that tan x 2x is exactly the same as what was on the left-hand side, 1 minus cos 2 theta. So I'll rewrite this 3 tan x bracket 1 minus cos 2. We're using x here instead of theta. So that's what this has become. Let me write down what's on my left-hand side, sec squared x minus 5, 1 minus cos 2x. So it's an equation here that we're solving, so I need to write all of it. I can't just write down left-hand side or right-hand side. That's the difference between prove and show that, where you're going from one side to the other. And equations, you have to manipulate the whole equation as it is. So you write equation and you go down. Now, from this stage here, we can see that, first of all, we can tidy things up a bit. Okay, we can we can see 1 minus cos 2x appearing on both sides there. So one of the things that we would do at this stage is get everything equated to 0. So I'll have sec squared x minus 5, 1 minus cos 2x, minus 3 tan x, 1 minus cos 2x equals 0. Okay, from this stage here, I can see that 1 minus cos 2x is a common factor in both of these terms. I've got one term here and a second term here. So I'm going to factor this out. So I'm going to write down 1 minus cos 2x, open bracket. I'm using square brackets because I'm going to have a few other brackets inside. Sec squared x minus 5 minus 3 tan x, all equaling to 0. So this is a factor that I've taken out, 1 minus cos 2x, because it appears in both of them. Now, from here, I can go and start solving. It's in a factorized form. I know it looks quite complicated, but let's take a look at each of the factors in turn. So I can say here, first of all, this factor here could be equal to 0. To get an answer of 0, one of these must be 0. So we could say 1 minus cos 2x equals to 0. Or I could have this second factor here, which is all of this. This whole thing could equal to 0. So this is now thinking about trig equations. If we've got it in a factorized form, we can then focus on each of those factors individually. So we've got sec squared x minus 5, all minus 3 tan x equaling to 0. So this again is another equation that I've got here, which I need to think about how to solve. So how can I solve this? Well, I've got sec squared here and there's a tan. So I'm thinking at this stage, okay, this becomes a trig equation solving strategy. Well, how do we solve trig equations? First of all, check the angles. Well, the angles are the same. I can see here x, x. And then I've got tan and sec. So I'm thinking, do I know an identity that relates tan and sec? So I can simplify it to a single function and I can think of one. Sec squared x is equal to, I'll just make a note of it here, sec squared x is equal to 1 plus tan squared x. So I'll go and use that. So replace that sec squared x with 1 plus tan squared x minus 5 minus 3 tan x equals to 0. And we can tidy this up a bit to get this equation here, which is just involving tan. And this equation that I've got here can be tidied up a bit because we can factorize this. So tan squared x minus 3 tan x minus 4 can then be factorized into tan x minus 4 and tan x plus 1 equals to 0. Okay, so then this equation itself, which is factorized now, means tan x minus 4 could equal to 0, or tan x plus 1 could equal to 0. What was the original one? That one there was 1 minus cos 2x could equal to 0. So look at what we've ended up with from that complicated looking equation, but by applying our strategy of keeping factors, and if we keep it in a factorized form where we can solve and then try and get each of the factor to have only one trig identity in it, trig function, we can then get it into a stage where we can solve. So from here we would go and apply our solving strategies, which I'm not going to go through here because that should be the more easy part. We're focusing on the skill of getting to the stage where we just have one trig function.